Hi, this is Professor V.K. Patil. I welcome you to my video classes on basic electronics. In my last class, we have discussed about the adder circuit. In adder circuit, we have discussed half adder, full adder. In full adder, we have discussed how to implement the full adder by using two half adders also. Today we will see what is multiplexer. Basically, multiplexer is a data selector. So it is also known as data selector, most commonly abbreviated as MUX, M-U-X. So it is most commonly abbreviated as MUX. It has n number of input lines. If you consider the block diagram, so it has n number of input lines. Let us say from I0, I1, I2 up to I of n minus 1. So it has total capital N input lines. It has 3 select lines. So these all are input select lines as well as I0 to I of n minus 1. So these are input lines. So the select lines of S0, S1 up to S of n minus 1. So it has small n select lines and it has only one output line. So this is the output line, let us say F, and this is nothing but n as to 1 multiplexer, n units, that is multiplexer. It has capital N number of input lines, that is I0 to n minus 1. So these are nothing but the input lines. Here we have, these are select lines. This is the output. In this MUX, capital N, which is equal to 2 raised to n, where this n is nothing but the number of select lines. Understood? So here we have capital N, which is equal to 2 raised to n, where n is nothing but number of select lines. This is nothing but the multiplexer. So this multiplexer, it can be used to implement the truth table directly. So that is nothing but some of the Boolean expressions can be easily implemented by using this multiplexer. That is nothing but the application of multiplexer. For this, let us consider a simple example. How do I can implement the truth table by using this multiplexer? Apart from these input lines, select lines and output, so it has one more input which is nothing but the enable. So this pin is nothing but the enable, E, right? So what happens in multiplexer is, by using these select lines, I can choose any one of input line. The data which is present on that selected input line will be routed to the output line when enable is active. Understood? So by using select lines, I can select any of one input line. The data present on that input line will be routed to the output line when enable is active. That is when enable is high. Right? This is nothing but a multiplexer. So let us consider the truth table. So we have the inputs which are enable. Then let us consider here for simplicity only the two select lines, that is S0 and S1. S1, S0, these are input lines, and depending upon that we need to select the input line. So when enable is 0, that is what, it is not active because it is connected to the E. So when I give the low signal, so it is inactive. So when enable is inactive, whatever it may be the values of S0 and S1, so this cross indicates it is don't care. So whatever it may be the values of S0 and S1, it may be the 0 or it may be the 1, output I am going to get a 0, right? So output will be a 0. When enable is 1 and these both are 0, 0, so when these both are 0, 0, so I0 line will be selected. When enable is 1, S0, S1 is 0, 1, I1 line is selected. When enable is active, S0, S1 status is 1, 0. I2 is selected. 1, 1, 1. I3 is selected. So this is the truth table. We will see how to implement this by using the multiplexer. Now here we have only the two select lines, right? So therefore capital N, it will be 2 raised to 2, which is equal to 4. Hence I need 4:1 multiplexer, right? So here we need 4:1 multiplexer. What is this 4:1 multiplexer? It has 4 input lines, which are nothing but I0, I1, I2, I3. This is 4:1 multiplexer. It has only one output line, that is F, enable pin, then 2 select lines. So these 2 select lines are S0 and S1. This is how I can implement this particular truth table. The one way of implementing this logic is by using gates, right? So how do I can implement? So I can write from this truth table the F, that is nothing but output, which is equal to I0, right? So I can write this as I0, S0 bar, S2 bar, S1, S2 complement plus I1 into S1 complement S0 plus I2 S1 S0 complement plus I3 S1 S2, I3 S1 S2, which is multiplied by or ANDed by enable input, that is nothing but E. Now if I simplify this, I will get this as I0 E into I0 S1 S0 complement plus I1 S1 complement S0, which is ANDed by E, plus E I2 S1 S0 complement plus E into I3 S1 S2. Now to implement this, I need 4 AND gates and 1 OR gate. Let us see that implementation. Now how do I can implement this? Now I need 4 AND gates, is it right? So let us draw these 4 AND gates first. All of these 4 AND gates, they must have 4 inputs, 1, 2, 3, 4, right? Because we know that multiplication can be achieved by using the AND gate and addition can be achieved by using OR gate. Hence we need here AND gate and OR gate. So output of this AND gate, let us say this is the output of first AND gate, second, third and fourth. So all these are added, hence we need one OR gate. So we need one OR gate. Let us say somewhere here we have OR gate and output is F. Where input to this OR gate is this is what implementation of this product, which is added later on. Now what are the inputs to this AND gate? Now inputs to this AND gates is S0, S1. Let us say this is the S0 line. We have S0 line, S1 line, then S0 complement, S1 complement and enable. Let us say this is S1, S0, S1 complement, S0 complement and enable. Now here what are the inputs? E, I0, S1 complement, S0 complement. So S1 complement, S0 complement, E is the one input and another input is I0. Now output will be this first. Similarly here, I1 is the input. Let us say this is the I1, which is input. another input is enable pin, okay, then S1 complement and S0. So here we have S1 complement and S0. Okay. Next we have EI2. So this is the enable input. Another input is I2. Then status for S1 and S2 is S1 S0 complement. So I will get a S1 somewhere here. So this is what the S1 and S0 complement and S0 complement. These are the input to this third. And now last where we have inputs are S1, S0, enable and I2. Now if we go on writing the intermediate output, this is the AND of this I0, E, S1 complement, S0 complement, hence you will get a output E, I0, S1, S0 complement. So this is nothing but the first output. Here we will get E, I1, S1 complement, S0. Here we get E, I2, S1 complement, S0. And here we get output E, I2, E, I3, S1, S0. And these all are added and finally we get output. This is the one way of implementing the multiplexer. This is all about the multiplexer. In my next class we will see one more circuit called as the decoder. Till then, thank you.